Hello and welcome to Read the Source. I'm your host today, Justin Ribeiro, and today we're learning about Elm and Elm CSS. Richard, Amy, please introduce yourselves to the audience out there.
I guess I could go first since Richard is the big guest here. My name is Amy Knight. I am going to be working for a company called Qualico in Salt Lake City starting next week, and they are experimenting with Elm, so that is why this is of interest to me.
Cool.
Fantastic.
I'm Richard Feldman. I work for a company called No Red Inc., and we are totally hiring. We use Elm in production for basically as much as we possibly can, and it's been going really well. And so based on my experiences with Elm and getting more and more involved in the community and knowing more about it, I've written a number of libraries and tools, and I'm actually writing a book now for Manning Publications, Elm in Action, due out probably about a year from now. But yeah, today I guess we're going to talk about Elm CSS, which is one of the tools I've made.
So tell us a little bit about Elm CSS before we screen share and dive into this code.
So basically, the idea for Elm CSS was essentially the question of, can we do any better than just having a completely decoupled CSS preprocessor, or is there some value we could get from sharing code between the view and the CSS preprocessor? The specific thing that I was wondering is that I've always had this problem in CSS where I'm not sure if I can safely delete things. I've got some old classes, some old ID selectors, and I'm like, I think these are dead. I think we're not using them anywhere. And if I'm lucky, then they have a nice grep-friendly name. I can search throughout the code base, see if they're still being used anywhere. But if I'm not lucky, they have some very common name, and I just get a ton of results, and it's going to take me too long, and I just have no idea if it's safe to delete or not. So I end up leaving them there, and the bloat just lasts. So kind of my question was, since Elm has this really nice compiler that is able to detect when things are missing or misspelled and things like that, is there some way that I could integrate the two and write a CSS preprocessor where the language that you write your style sheet in is Elm, so that you could share code between your CSS preprocessor and your view code, and that way, when you delete a class in one place, the other place will break. You'll get a compile error if it still exists in the other place. So you can essentially have all the nice refactoring benefits that Elm gives you in the view in your style sheet as well.
That sounds like a very powerful feature. So how about we take a look at that very powerful feature with source code?
Sounds good. I guess I should share my screen.
I would share mine, but it would probably have just a jumble of just windows and weird words.
Sure.
Ooh, that's pretty. Right. I'll leave you to it, Richard. Drive us into the wonderful world of Elm CSS.
Okay. So I've never done read the source before, so if you want to give me any guidance or tell me if you have any questions or stop me along the way, feel free. Otherwise, I'm just going to talk and we'll see where it takes us. Okay, so I want to start by just showing an example of one of these style sheets. So this is some Elm code. The top of every Elm file, you have this module declaration that says this is the name of my module. So in ES6, you have these ideas of modules where you can import them and share them around one another. Elm has that built into the language as well, but it's some more powerful features, which we may or may not have time to get into. So I'm importing a few things here. So these are some other modules that I'm importing. So the CSS module, CSS.elements module, Namespace, which is a separate feature that I added on later, and shared styles. And so we'll get into all of those in more depth later. So this right here, I'm assigning this CSS identifier to our actual style sheet. So if I weren't using the namespace feature, this would just look something like this. So I'd be calling style sheet, passing all these arguments. So this is a list in Elm, it's square brackets. The convention in Elm is to put the commas at the beginning of the line, but this looks essentially the same way as a JavaScript array literal would, except that it's a linked list under the hood instead of an array, because that tends to be what you want to use in Elm for performance reasons. So we're saying we're calling this function called style sheet, and we're passing this list of styles. and each of these does something slightly different. So I think the best way to illustrate this is I'm just going to bring up the output that this spits out. So this is my test fixture. So this is the test file. When my unit tests run, it runs through, compiles this, and then verifies that the compiled output on the left from compiling the style sheet on the left is the CSS file on the right. So what Elm CSS does is it goes through all this stuff and it generates all this stuff. So in the same way that Elm compiles to JS, Elm CSS compiles to CSS. So this is not something where you're going to integrate it directly into your views with inline styles. This is something where, although you're still sharing code with your view, what you're getting at the end of the day is a compiled CSS file that lives alongside your JavaScript files and has all the same performance characteristics, caching characteristics, and all that good stuff as traditional loading CSS files in the browsers has always had. So first things first, so we have this header here. So I say header, that corresponds to this line. Background color corresponds to this, box sizing, padding, and so forth. So a couple things to note here. One is that this right here is just a normal Elm function. So I have a function called background color, and I'm passing it one argument. So in Elm, when you call functions, you separate the arguments with white space rather than with parens. So maybe in JavaScript, this would look something like this. You also don't use commas to separate your arguments. But essentially, this is what's happening right here. This is the JavaScript equivalent of that. I'm just calling the background color function, passing the results of the RGB function, which makes a color. I'm going to do all that. Now, let me keep that going. Okay, so we have the background color, and that's going to compile out to background color RGB 909090. Box sizing, border box, same deal. Padding, same deal. The reason that I have a function called px is essentially just to make this work with different unit types without having to do crazy tricks. So there's no syntactically valid way in Elm to write this, just -80px, just like that. You couldn't write that in JavaScript. The compiler would just say, I don't know what this is. So that is one of the trade-offs that you get. So on the one hand, you have this entire power of Elm at your disposal, which means that I can write any kind of helper function I want. I can write any kind of module. I can use modules. I can have stuff that shares code with my views. But what I can't do that Sass and other preprocessors can do is I can't define custom syntax like this. So functions are sort of what I have to work with. And so things are going to inevitably look a little bit different because of that. Okay. Questions so far?
That looks pretty good.
Okay. Cool. So that's what generates this first thing. Nav, kind of the same deal. So this one is a little bit different. So this is a class. We have nav link. So I'm going to uncomment that namespace thing. So this is the namespace feature. So homepage namespace .name comes from shared styles. So this is all that is. It says homepage namespace is a namespace called homepage. And what that means is that essentially when I use this namespace feature, it's going to go through and add whatever I specified as my namespace, which in this case is the string homepage. It's going to add that as a prefix to all of my classes, IDs, and animation names. So the idea behind this is that you specify a namespace in one place, and then for the rest of the entire style sheet, you now have this prefix that gets prepended to all of these so that there aren't namespace conflicts with other style sheets that you might have loaded on the page. So for example, here I'm defining a class called navlink. Maybe I have another style sheet that's using something like navlink as well. Something like hero or maybe menu is also pretty likely to have namespace collisions. But by using this namespace feature, I can make it so that I automatically take care of those things without having to go through and say, this is homepage navlink, this is homepage reactive logo, and this is homepage buy tickets, etc. I just do it in one place, and it automatically gets spit out on the side. So the implementation of that is actually really cool, and I'll get into that later. But basically, that's why, although here I'm saying .navlink, I get .homepage navlink, and I'm saying # reactive logo, and I'm getting homepage reactive logo. It's that namespace feature. Okay, so the next thing you might be wondering is why is it that I'm doing this weird looking thing instead of having like where we have header and nav, why don't I have something like class here? So there are two reasons for this. One reason is that one of the potential use cases for this is that since this is all written in Elm code, it's possible if you want to define your style sheet in the same file as you're defining your view and just pass that entire view file to both Elm CSS to generate the CSS file, in which case you're going to have a bunch of view code that it's just going to ignore, or pass that same file, I guess, and I should say, and also pass that same view file to Elm to compile out the view, in which case you're going to have a bunch of style sheet stuff in there that it's going to ignore. So in order for that to work out, it's really important that I don't have any clashes between the functions that I'm using in Elm CSS and the functions that I'm going to be using in my view function, or in my view file. Otherwise, you could try and do that, but what you're going to get is a big mess. And class is one of the functions that's used in Elm HTML when you're defining your what your DOM is going to look like. So in React, they call that class name, but because class is not a reserved keyword in Elm like it is in the future versions of JavaScript, we can just use the keyword class for our, or it's not a keyword, we can just use the name class for that function. Same thing with ID. So I could have just called this ID, but then I would have a namespace clash if we were ever using this in the same file as something that was using Elm HTML. Okay, so that answers why I didn't just call it the sort of more clear candidate for what to call those things, but it doesn't answer what I'm doing with these crazy parentheses. So the parentheses are actually operators. So in Elm, you can define your own operators if you want. You can, so we have plus as an operator. You know what? I'm just going to bust out Elm REPL real quick and just show you that. So if I say 5 plus 6, okay, it gives me back 11. If I say, I don't know, foo plus plus bar, plus is the concatenation operator. So each of those things, plus and so forth, those are all operators. And operators in Elm are just normal functions that take two arguments, and their names are entirely comprised of special characters rather than letters or numbers. So functions can have letters and numbers, and operators can have special characters, but you can't mix and match. So a feature of operators is that you can use them in this infix style, which is how you can say something like 5 plus 6 equals 7 plus 8, and that will give me back false because those aren't equal. But it's important to note that plus is an operator, equals is an operator, and plus, again, is an operator. So we only have an hour and a half, so I can't get super much into what Elm's type annotations mean. But essentially, this right here is saying, okay, the result was false, and then the part after the colon is saying what the type of the result was. So I'm saying 5 plus 6 equals 7 plus 8. All of that entire expression evaluates to a Boolean, and the Boolean's value is false. Now, so if I want to take a function, like let's say I want to take the function not. So not is a function that takes a Boolean and returns another Boolean. So if I say not true, it gives me back false. If I say not false, it gives me back true. So it's a function that takes a Boolean and returns a Boolean. As it happens, operators are also functions, but I can't just write plus into here. It's going to say, like, that's a syntax error. I don't know what you're talking about. If you want to take operators and use them not in an infix style, which is how they're normally used, you have to put them in parentheses. So if I do that, it says, oh, yeah, that's a function, takes a number, and then another number, and returns another number. If I want to say equals, put that in parentheses, it says, oh, okay, cool, that's also a function. It takes an A, which is to say anything, and another anything, and then returns a Boolean. So I can do this for absolutely anything I want. Division, multiplication, plus, that concatenation thing for strings and so forth. They all just work that way. So the one last thing you need to know about operators is that you can also use them to call things in this way. So instead of saying 5 plus 6 I can say plus in parentheses, which has now turned it into sort of a normal prefix style, and just pass it to arguments 5 and 6, and it'll do the same thing. Okay, having said all of that, I am arguably abusing that fact to define a custom operator called plus, which is essentially exactly the way I would implement something like class. And I've just chosen to use an operator because, as it happens, this is a function that's taking 2 arguments. So the first thing is the class that you want, and the second is a list of all the styles that are going to go into that class. And since operators, the only rule is that they have to take 2 arguments, I can get away with doing this. So it looks kind of, if you squint, it kind of looks like a dot like you would see in normal CSS, and this kind of looks like a pound. And this lets me get away with having something that is at least reasonably intuitive and easy to learn, but which does not have namespace conflicts if I wanted to use all of this in the same file as Elm HTML stuff. So that's a drink from the fire hose. Hope everybody's having a good time so far. Okay, so we've now looked at header, nav, navlink, reactive logo, and buy tickets. So we see why all of those are doing the things that they're doing. And that's basically this entire style sheet. This namespace here is specifying where the home page bit comes from up front. And there's not a whole lot else left to look at here. So let's start getting into how all of this happens. So behind the scenes, there are 2 different steps going on here. So first I have this sort of surface level DSL, which is to say I have all of these helper functions, like header is a helper function, background color is a helper function, box sizing, padding, nav, dot. All of these are helper functions. Oh, you know what? Actually, I just realized. Okay, before I get into that, I should probably explain why these are capitalized. So the reason that navlink is capitalized and reactive logo is capitalized, that is not a coincidence. That is the aforementioned feature around sharing code between our view and our style sheet. So over here in the shared styles file, this is the only file that's going to be shared between the style sheet and the view. So the view is going to import this module, and the style sheet is also going to import this module, hence why it's called shared. But the view is not going to import that entire style sheet, because if I did, that would add a lot of bloat to the compiled output. That would just be a bunch of stuff that's not necessary to live in the compiled JavaScript, so there's no point in doing that. But by just importing this tiny shared styles thing, it's not a big deal. And all this is doing is it's defining essentially some enumerations. So I'm saying here are all my CSS classes. In this case, just navlink, but I could add some more. I could say menu, I could say hero, I could say something. I can just add as many of them as I want. And now those are my comprehensive list of all the CSS classes that are going to be used in this file. Currently, it's just navlink. Okay, and then I can also do the same thing for my IDs. If I want to, I can also do the same thing for my animations, but I didn't have any animations on this page, so I didn't do that. So this is what's called a union type in Elm. And union types can do quite a few different things, but in this case, we're just using them for their most basic feature, which is to serve as an enumeration. So essentially, these are constants where it's guaranteed that I can't mess them up. So if I have something that's using one of these things like reactive logo or buy tickets or navlink, and I have a typo, that's going to be an error. Whereas if it were just a string or something like that, I could mess that up, and the compiler would have no idea that I messed it up. So let's try that. So right now I'm gonna. So I have Sublime Text open here. I actually use Vim normally, but I figured Sublime Text would be a nicer UX. I've been a long time Sublime user. I just recently switched back to Vim. But it has this really nice integration with Elm, so I can just pull up this menu and say I want to Elm make, and it's going to give me an error because this is my test file. Okay, so I guess I'll have to show that a little bit later. Actually, I guess I can just come out here and do it in the console. So let's see.
Digging the Z shell there, digging it.
Oh yeah, Z shell's great. Let's see. So where is it? Is it in fixtures? Oh, where is it? Thought I saw it maybe I'm wrong. Where is this file? Oh, examples, right. CSS. Ah, all right. Okay, I probably broke this. I was messing around with this morning and last minute. At any rate, point being, the compiler can check these things between these two. Take my word for it, or after I fix it, you can check out the the repo and take my word for it, and not take my word for it, to actually try it out. So these are enumerated values, and then over here in homepage view, we have this whole view structure, which I guess I can get into in a second, but for now the main thing is, here's the aforementioned ID function that specifies the ID for this image, and we're saying reactive logo, and the compiler knows that that is the one that we've got in shared styles, and so it's not going to let me mess that up and have a typo, and if I delete it in one place, then it's going to give me an error if I delete it in shared styles, or if I delete it in 2 out of the 3 places, then all the other places are going to break. So basically, if I delete anything, if I delete this right here, if I say the only CSS ID that's allowed is buy tickets, and then I try to recompile this, then it's going to break. It's going to say, nope, you can't do that. You don't. I don't know what that is, but you've deleted it. So using that, I can basically be confident when I'm deleting things that I'm not using them anywhere. Because if I delete reactive logo and the compiler gives me an error, I know I must have been using it somewhere, and in fact the compiler will tell me exactly where I'm still using it. And if I delete it and everything still compiles, then I'm like, great, it actually wasn't being used anywhere. Okay, so this view stuff, this is essentially the Elm HTML DSL for rendering views. And this works almost exactly the same way that React does, except a little bit simpler. So there's no JSX equivalent in Elm. It's just all plain vanilla Elm. So we have a function called div, and all of these HTML functions, I'm going to assume because we only have 60, 90 minutes here, that I can't give a total primer on virtual DOM. So if you're lost in this next section, I encourage you to look up either React or the Elm HTML tutorials to figure out how virtual DOM stuff works. But assuming you know what virtual DOM is, that's what this is using. So div is a function that takes a list of attributes and then a list of children. And that's how basically all of these work. So we have here we have a div that has a header child and another div for child. We have an image which has an attribute here, so this is its list of attributes, and we have a source attribute, but we do not have any children because image tags tend not to have children. Here's a span that has an attribute with an ID of buy tickets, and then for children it only has a text node that says buy tickets. So you can kind of get the general idea. We have a div with headers inside it and a div inside that. The header has an image, a nav, and a span, and then each of those have varying degrees of children and attributes going on in there as well. Okay, so that's our view, that's our shared styles, and now I think we've covered sort of the motivating use case. With a simple style sheet like this is not a big benefit. The idea is that if you have a very large code base, which we certainly do at No Red Ink, we're not using this yet because Elm CSS is not ready for production yet, which I have this big all caps warning at the top of the repo that says, not production ready yet, please don't use this yet. But still people are using it because it's cool.
Cool things get used. I mean, yeah, that's that.
Yeah, it's what you get for putting it out there. But honestly I appreciate it because I'm getting lots of good feedback. I didn't actually realize, I thought I could get away without having a mix-in system, and then my coworker Noah was using this for a project, and he was like, hey, I need mix-ins, and I was like, oh, can't you do it with these things that we already have? He's like, no, here's why not. And I'm like, oh, you're right, we need mix-ins. So now we have mix-ins. And we will get to the implementation of mix-ins in a bit. Okay, so let me go back to here. I don't want to show that yet without explaining the motivation first. Okay, so we start off with this DSL. So I'm just going to make some comments here so I can explain stuff. So this is a block comment in Elm. It's the equivalent of this in JavaScript. So I want to start off with this DSL, and that's what the end user reads. And then I want to do some stuff, and then eventually I'm going to get all the way to a CSS file. So along the way, there are two intermediate representations that I use. So the first is, actually let me talk about the last one first. So the last one is called structure, and this is essentially structure. The purpose of structure is to represent, as well as I can, the structure of a style sheet. And that's having nothing to do with Elm CSS, that's just CSS. So this entire structure module is something that actually could reasonably be pulled out of Elm CSS if that's something people are interested in. I don't know if other people would have a use for that, but I could totally do it. And all it's concerned with is modeling as well as possible a CSS file, like the way that a style sheet needs to look. So all the different pieces that go into a style sheet, all the different declarations, basically trying to nail down what makes a valid style sheet and capture that in code. And the reason that I'm doing this is because Elm has this great compiler that catches lots of errors. And if I want to have that good error handling and all of the nice refactoring benefits and things like that that it gives me, it's really important that I'm able to model those things in a way where when I'm going through and making changes, I can... sorry, I'm hearing a bit of a echo. Is there somebody mute, maybe?
I will double mute.
Let's see. All right, seems to have gone away. Cool. Sorry about that. Yeah, so the purpose of having this structure and defining it all out like that is so that when I'm going through and making changes, I can get all of Elm's nice refactoring capabilities and all of the help that the compiler gives me that I'm used to, rather than just working in raw strings. So by putting in this intermediate representation, I give myself something that's easier to debug than if I were just going directly to the strings, which is actually what I was originally doing, and then I realized that I had this need and that life would be easier if I did that. And then, after talking with Evan and Noah and some other people, I kind of realized that I actually wanted something before that, which is I wanted to have an internal representation of what the DSL was outputting. So basically, the DSL generates this structure called the pre-process structure, and that is sort of a representation of all of my mix-ins and nested declarations and all these things that are sort of SAS-like about Elm CSS. And then I have some functions that translate from this pre-process structure to the CSS structure, and then some stuff that translates from the CSS structure to the actual CSS file. So that may or may not have all made sense, but I'm going to go through each of those one at a time. So let's start with the structure because that's the one that you're probably most familiar with. Let me go back to one view here. So like the comment says, this is a representation of the structure of a style sheet, not concerned with Elm CSS or anything else. I guess I've got to finish that comment now. Like I said, not production ready. Okay, so let's just go through what each of these are doing. So first we have this type alias called property. So type alias, in this case, is essentially saying, I want a record, so records in Elm are essentially like objects, that has this shape. It's got a field called important, it's got a key, and it's got a value. So for example, in JavaScript, this would be the equivalent of saying, I want something that looks like this. Important, true. I'll put that at the end because that's usually how people think about those. Let's say key, background color, value, RGB 12, 13, 14, important, true. So as you can imagine, this right here is a representation of a CSS property. There are three elements to it. It's got a key, it's got a value, and then it's either important or it's not. Important being bang important. So this would compile to background color RGB 12, 13, 14, and with bang important because I set it to true. If I set important to false, then Elm CSS would not output the bang important. So all this is saying right here is I'm going to name this thing called property, and properties are all going to look like this. They're going to have those 3 elements with those 3 types on those elements. Okay. Then we've got another type alias, which is for the style sheet as a whole. So this one came out, I didn't originally have this one. This one came from learning more about the CSS spec, which is a really enlightening read. It's really astonishing how much CSS you can do while having so much missing knowledge, because the spec is just absolutely enormous, and a lot of these things just don't get used very often. So these 3 features are actually things that I've never used. Char set, or character set for short, imports, and namespaces. So the way these work is you have something like at charset UTF-8, or maybe you're using something else because you have some different needs than I do. Import is you can import other style sheets, foo.css. Namespace is, I don't honestly remember what it does, but it's something similar to this namespacing feature that I added into Elm CSS, except in a first-class kind of way. And then you have all your declarations. So the declarations is the part that we all sort of know so well. It's the button looks like this. Some colors here. That'll look beautiful. Okay. What I learned about these things, I thought initially that I could implement them as normal @ rules. So I have support for a variety of different @ rules. So media queries being by far the most common, right? So @media, and then say print or screen or whatever the case may be, and then you specify certain dimensions, and good things happen. But I didn't really have much experience with these. So initially I thought that since they look like media queries, you could use them like media queries. Turns out that's not true. As it turns out, they have very, very strict rules about how you can use these 3. So charset is the strictest. Charset, literally, if you're going to have one, it has to be the first character in your style sheet. Like these exact, 8 characters, have to be the first 8 characters of your style sheet if you want to use this. If you put it anywhere else in the style sheet, it's an error. Did not realize that. And then if you want to use import, all of your imports have to come after charset if you have one, or if not, then they have to be at the top. And you have to do all of your imports before you do any namespaces. And then you can have as many namespaces as you want, but again, the namespaces have to be after the imports. And then you can do the rest of your style sheet as normal after all that stuff. But because they had these really strict rules, I realized that my initial approach of sort of folding those into the declaration, just making them normal declarations like media queries and like anything else, wasn't going to work, because my goal with this file was to say I want to represent a valid style sheet, not just a potentially valid style sheet, but I actually want to, to the extent that I can, make it so that if my style sheet is invalid, it won't even compile. Because that's going to make it the easiest for me to debug things. So I figured out that to do that, what I actually needed to do was I needed to make this a record, and I need to say, okay, you have a char set, you have imports, you have namespaces, and then you have declarations, and they're all totally separate. And that way, when I have my output file, which has this pretty print thing, I can start by doing each of those in turn. So when I'm calling pretty print, which is what actually spits out the string for the style sheet, I start by doing charset to string on the charset, and then I join all the imports together with new lines. I join all of the namespaces with new lines. Then I join all the declarations. So by doing this, I basically make it so that there is no way to have a char set anywhere but in the first position, because the pretty printer itself is taking care of only ever printing it in that position. And likewise, it only ever prints the imports after that, and the namespaces after that, and then all the other declarations come later. So it's actually extremely difficult to mess this up now. Okay, so that's the motivation for setting this up. You might then be wondering, okay, I understand what a bool and a string are. What are all these crazy things? Let's go through those. So declarations it's a list of declarations. So a declaration is something I've defined down here. This is another one of those enumerations. So actually, let me pop down here for a second, and then I'll come back up to style sheet. So we saw over in shared styles how we had an enumeration of different CSS classes and of different CSS IDs. So this is the same kind of thing, except it's a little bit fancier than just a straightforward enumeration like those were. So here I'm actually sort of mixing. These are called union types, and I'm mixing, some union types with others. So this is an enumeration of all of the different types of declarations you can have in CSS. So I actually went through. I didn't actually go through the spec for this because the spec's a lot harder to read. I went through MDN, but I basically listed all of the different things that you can have in a style sheet. And it turns out here's what they are, and I actually linked to all of the MDN articles. So you can, if you're reading the docs on this, you can see where these come from. So you have style block, media rules. Each of these are different at queries. So media rule would be at media. Supports rule would be at supports. There's a bunch of these, as it turns out. And the reason I did different ones is that they all have different arguments that they take. So style block declaration, again, that's the sort of standard one that we spend 99% of our time dealing with, which is just normal style declarations. But there's all these other ones, and they all take different sort of shapes of arguments. So supports rule takes a string. I don't remember what that string does offhand, and then takes a list of declarations. Page rule takes a string and then a list of properties instead. Media takes a list of media queries followed by a list of style blocks. Viewport takes a list of properties. They're all different, and I wanted to make sure that when I'm pretty printing them, that by the time they made it this far, all of the representations were definitely sane. They were definitely set up the way that that I needed them to be in order to print them properly. So this sort of allows me to narrow down what I'm debugging. So if something breaks, if I see some unexpected output, I at least know it wasn't because things weren't wired up correctly or that things were passing crazy values to other things. I know that it's something outside of this. Like it must have been in an earlier step than this, because once they get into this representation, I can see right here that, like, okay, definitely media rules have a list of media queries and then a list of style blocks. It's not possible for them to have, like, instead of a list of media queries, like a number here. The compiler would give me an error if I tried to create a media rule where instead of a list of media queries, I was giving it a number. Questions on all this so far?
No, you're doing awesome. This is you're really helpful and very clear.
Yeah, you're smooth as silk, Richard. Keep on rolling.
All right, cool. I'm gonna keep rolling. All right, so whereas previously we just had these sort of simple enumerations where we just had just one thing and we're just sort of using it as a constant, here we're nesting them. So these are actually not only enumerating the name of the thing, but also what data goes inside it. So the media rule has this data inside it. It has these two different pieces of data, the list of media queries and the list of style blocks. Okay, so all of these go into a declaration. And you notice that we're using these sort of parameterized types in different ways. So this is a list of media queries, this is a list of style blocks, and up here we have a list of declarations, which is to say I have a list of all of these things. And they could be mixed and matched. So we could have one of the declarations is a style block, then maybe the next one in the list is a media rule. Maybe after that there's another style block. Usually there's a bunch of style blocks in a row, realistically. Maybe there's a supports rule after that. Could be in any order we want, but all of them are one way or another a declaration of some sort. Okay. Last thing to note on this type alias is what these are. These are tuples. So a tuple is essentially when you want a record like this, but you are too lazy to come up with field names, which is what I am here. So if I had not been lazy, so these namespaces, the way that namespace looks is it's at namespace, and I believe it's then, what is it, URI? No, prefix, that's what it is. Prefix and then name. That's how they look. So I would say namespace, yeah, prefix and then name. So essentially what I could have done here is I could have said type alias namespace equals, and then I could have said prefix, which is a string, and then name, which is a string, and then I would have been done with it. But, and then I would have said list namespace. but I was too lazy for that, so instead I used a tuple. Incidentally, despite the fact that I did that, oh, you know what? Okay, sorry. So let me compile this. So this should, okay. That, oh, I'm not using this anywhere. Right. Okay. Uh, yeah, let's just say if I wanted to, I could just use string comma string, and that would be an acceptable namespace. So I could use this type alias feature if I want, but again, I was pretty lazy because I don't actually use these namespaces, so I just put it all in line like that. Okay. That's tuples, union types, type aliases, records, and probably other things I'm forgetting. So all of that is how we end up with this structure. Some interesting stuff down here, if you're into CSS, is this is essentially a really carefully enumerated way of how you build up a selector. So this might be interesting to people, so I'm going to go through it. So let's say I have a selector like foo. That's a pretty straightforward one. According to the spec, every simple selector, actually let's start with one called button. So every selector starts with either a type selector, which is to say it corresponds to a tag like this, an element tag, or the universal selector, which is called asterisk. So in other words, you may or may not know this, but every single selector you write, if it doesn't start with one of these, implicitly starts with one of these. It's just that you're allowed to omit it if you have other stuff going on. So whenever you write pound foo, you're actually writing star pound foo. You just don't actually write out the star because you wouldn't bother. So using those two ideas put together, we can tell that almost all of our selectors are going to start off that way. With a star, except for the ones that start off with a tag instead. So after that, you can do a couple of different things. You can have IDs, and you can have classes. You can have pseudo classes, and then you can have up to one pseudo element at the very end. So a button. Let's say we had to say button sign up, and then dot big dot blue. And then, so that would be a selector with a type selector at front, and then it would have an ID selector after that, and then it would have two class selectors. And then, let's say we wanted to say on hover, that's a pseudo class. You could actually have multiple pseudo classes if you want. I've never come across a use case for that, but theoretically you can. And then you can have up to one pseudo element. So this whole thing right here, unless I'm mistaken, which is always possible, is a valid CSS selector. And so my goal was to model these things according to the spec while still making them valid, and making it sort of impossible to represent an invalid selector. So here's how I did that. So we have, let's ignore this last one because I added it sort of as a backdoor. So we either have a type selector sequence or we have a universal selector sequence. And if we have a type selector sequence, we need to start off with a type selector, so button or whatever. We don't need that first parameter in the case of universal because there is only one universal selector, which is star. And then followed by that, we have a list of repeatable simple selector, which is to say all this other stuff that's going on in here. I added one called custom selector, basically as a backdoor, so people can use Elm CSS before it's totally ready. If there's some selector that I haven't implemented yet, you can just write this. So for example, if you want to write out button, that's already a function I have built in. It'll give you a button selector. But if you come across, let's say there's some new thing, or maybe even you're just using Polymer and you want to style some custom element, you can just write out selector and just give it the name of the selector, and it'll just sort of take it and treat it as under the assumption that you're giving it a valid selector. So I can give it a selector like hamburger, and then if I have somewhere in my DOM, for whatever reason, hamburger, maybe it's for hamburger menu. I didn't actually think of that when I said it, but now I've said it, so I'm going to roll with it and pretend that I'd planned it all along, and no one will be any the wiser. We can edit this, right? Okay. It's not live or anything. So, so this is our hamburger menu, and I want to style the hamburger menu. Here's how I will do it. Okay. So that's how a simple selector sequence works, and then repeatable simple selector is these are the three things that you're allowed to repeat. So type selector, you can only have one of them, or the universal selector. But classes, IDs, and pseudo classes you can repeat. I was a little bit surprised by this in the spec because it seems like if you wrote something such as button pound sign up pound something else, I'd be kind of like, well, this seems weird. Why did you give this thing two IDs? What would that even mean? I have no idea why that's allowed, other than that I guess they couldn't sort of syntactically forbid it, and they were, rather than making that be an invalid style, they decided to just accept it. Maybe there's a use case I'm not thinking of, but at any rate, it's allowed, so I have to model it that way. All right. What else? And we have selector combinators. These are so you have adjacent sibling, which is plus, general sibling, which is tilde, child, which is that, and descendant, which is that, or more commonly just a space. Okay. All right, so that's structure. Then this output, this is a structure.output, and it's the one that turns all these into strings. We saw that later. Here's some stuff that I'm not done with yet. Namespace, pretty print style block, pretty print declaration, take a simple selector and turn it into a string. All of these various two-string things. Some of them are more straightforward than others. This is probably the most straightforward one. If we have a class selector, then okay, cool. Take the string that goes with that class selector and stick it after a dot. If it's an ID selector, stick it after a pound. If it's a pseudo class, stick it after a colon. Pseudo element, kind of same thing, except just do it with colon, colon. Oh yeah, and here are those combinators we looked at earlier. One other thing to note, I intended to go over this and then totally forgot. Maybe. So Elm does not have a concept of null or nil or undefined or anything like that, which is one of the main reasons that we found it so reliable. So at No Red Ink, we've had Elm in production for the better part of a year now, and it has yet to have a single confirmed case of Elm throwing a runtime exception. And the reason for that is, in part, that the compiler is really good at checking for this stuff, but also that the APIs for the entire Elm language and basically all of its libraries are built around these really smart ways of representing uncertainty. So this import here is definitely a list. This namespace is definitely a list. This declarations is definitely a list. Charset, though, says maybe string. If it said string, then it would definitely be a string. But we don't always have a char set. Sometimes we don't have a char set. In fact, every style sheet I think I've ever written has not had a char set. So we need to have this idea of what if there is no char set. So kind of a hacky way to do that would be, oh, well, if we have the empty string here, then assume they don't want a char set. That's not really what we want. What we really want is we want something like in JavaScript, we would probably use null for this. In Ruby, we would probably use nil for this. It's just a thing you want to do in programming to say, I explicitly do not want to have a thing here. There's just no use for having that. So in Elm, that's called maybe. So what this means is that now I can no longer say, you know, my style sheet has a, this is how you define records in Elm. So I can't just say char set equals UTF-8. I could do that if this were taking a string, but it's taking a maybe string, so I can't do that. This will give me an error if I try to do that. Instead, what I have to do is I have to say just UTF-8. So anytime you have a maybe, you either have to say just, and then the thing that goes inside that maybe, or you can say nothing. So this would be valid, or this would be valid. But this would not be valid. I've forgotten to handle the maybe, and so the compiler will yell at me. So you have to do that when you're setting up the maybe, and then you also have to do it when you're taking stuff out of the maybe. So if I want, for example, to pull a value out of charset, I can't just say my stylesheet.charset and expect to have a string there. I won't have a string. I'll have a maybe string. So actually, let me just show that in Elm REPL. That's probably a good idea. Okay, so let's say I want to make a, yeah, let's call it charset. Equals just UTF-8. Okay, So if I say char set now, it's going to say I have just UTF-8. I do not have the string UTF-8 itself. If I want to get just the string, there are a couple of different ways I could do it. One is writing a case expression, but that's sort of more verbose than what I want to do here. The easiest way is usually just to give it a default, which is to say, I'm going to give you this default value, and if you gave me a nothing, then use the default value, and if you gave me a just, then use that. So I'm going to say maybe.with default no char set, yo. Char set. Okay, so that says UTF-8 because it didn't need to use that fallback because char set was a just. Now, if I passed it a nothing instead, actually, sorry, that's going to give us the same result. Now, if instead of that I pass it a nothing, now it's going to say no char set, yo. So the idea here is that the with default lets us safely unwrap the thing that's inside the maybe because we have to provide it with a fallback in case there's a nothing in there. So this is sort of like opt-in null handling. And what's cool about this is that you can never forget to do it. You can't just be like, oh, whoops, I forgot to handle null there, because if you forget, it's just not going to work. If so I can do like UTF, let's say, charset colon plus plus UTF-8. That works. I can do that because those are both strings. It puts them together. But if I try to do this with our charset variable, this is not going to work because charset is not a string. Charset is a maybe string. It's going to say type mismatch. Right argument of plus plus is causing a type mismatch. And actually, Elm has these like world-class compiler errors. So it even underlines the offending line and says, hey, this is the thing that's busted. It says plus plus is expecting the right argument to be a string, but the right argument is a maybe string. So it's telling me exactly what the problem is. And like I said, this won't even compile. This is never going to make it to runtime. This is just something that the compiler is going to tell me about as soon as I try to compile my program. So this is how we can have such incredibly long stretches of time where our Elm code's been running in production, yet we've never got runtime exceptions. It's from stuff like this, where you just can't mess up null handling. But it also doesn't get in your way, because the vast majority of the time you don't want something to be even possibly null or nil or nothing or undefined. It's only in certain corner cases where you even want that. And so as we can see, like I'm using maybe here, but I mean, where else am I using it across the code base? Like here's a place, and yeah, right. So like pseudo element, you can either have a pseudo element or not. I don't want to have a list of them because you're not allowed to have two pseudo elements. So maybe there's a pseudo element, maybe there isn't. That was in a comment. Yeah, so those are the only two places in this file that I'm actually using a maybe. All the rest of these are guaranteed never to be null, nil, undefined, or nothing. And I can just use them as normal. So it's sort of the best of both worlds. And having now used this system, I never want to go back to the land of null, nil, undefined, or what have you. Okay. Here's pretty printing properties. So we basically just slap a semicolon on the end, or if we have the important flag set like we looked at earlier, put important on the end. Indent is for pretty printing purposes. I just stick a bunch of spaces in there, which is why homepage.css, this compiled output thing, has indentations here. That's from this indent function. Okay. All right, so that's structure and output, but as you may recall, so that's the last half of this. So now we've seen the end of this, and we've seen the beginning. So this is the DSL in action, and we've seen the structure. What we've not seen is the intermediate step, the pre-process. So one of the other cool features about this is that it's not just taking straight CSS and then compile, except represented in Elm form, and then compiling to a style sheet. I actually put some sort of Sass-like semantics in there because I've used Sass for a long time and I really like it. And I think they're semantics worth keeping. So let's look at some of those. I think probably the best way to do that is by looking at the tests for them. Let's see. Oh, this is not what I want. I want fixtures. Where is media? Here we go. Cool. Let's once again do one of these. Actually, I'm just going to pull this over here. No, I'm in the wrong file. Go back. Okay, cool. So at rule, style sheet, at rule test. By the way, this is Elm test. So Elm test is what I use for unit testing, what we use at work for unit testing. Pretty straightforward test runner. I have it set up to integrate with Travis and all that good stuff so that I get test failures when I break things, and works pretty much the way you'd expect. Okay, so we have this at rule, and we want to use a media at rule. So this is the output of what I've got over here. I'm saying I've got a body with padding 0. By the way, the reason I came up with this special 0 thing is because normally you have to specify units here. So I have to say like px5. Before I added 0, you would have to say px0 or like em0, which is kind of lame when what you want to say is just 0. I don't care about the units. So rather than coming up with special units for 0, I just came up with a constant that's called 0 that just spits out an actual 0 with no units on it. Okay, so now I'm saying media print, body, margin 2em. So that generates this. So this right here is sort of the very direct one-to-one translation. So if I had no Sass-like semantics, that wouldn't be a big deal because this is just very normal CSS type stuff. Okay, the more interesting one is right below it, which is nested at rule. So here I'm saying I have a button with padding 0, so again, very boring. Then have a body with margin auto, also very boring. But then I have this thing called with media print, and then I'm specifying a margin of 2 EMs for that. So what's cool about this is that this is actually going to turn this into 2 different style declarations. I'm saying, okay, I'm coming along defining my body. Maybe I want to have a background color, purple, and I want to have like height 100%. But then I'm like, oh, you know what? Just for print media, like if I'm doing a printer-friendly style sheet, just for that one I want to have a 2 EM margin. So if I were doing the approach up here, I would have to basically say, okay, whatever selector I've got going on, which could just be body, but it could be, you know, a lot of stuff going on there, a lot of nesting. I would say, okay, I have to go back up to the top, and I have to say, okay, back up here, media, print, blah, 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 and go from there. So what with media lets me do is it lets me say, just keep all the selectors I've got going so far, whatever they may be, which in this case is just body, but could be, you know, arbitrarily many things. And I want to make a new declaration that is a media declaration based on all of those selectors and inside the context of this media query. And then I'm going to define some styles for that. So what this generates is this. So button padding 0, very normal. Body margin auto, again, very normal. And what this with media thing is doing is it's generating this other entirely separate declaration, even though I've nested it in the style sheet underneath the body that says, cool, just for media print, body has this. And then below we have another normal one, which is just links or text decoration none. So what this does is it lets me have the same feature that Sass has, which is that I can nest media queries inside whatever selector I've been building up so far without having to jump back up to the top and have code duplication. So in order to support a feature like that, I can't just go directly from the DSL to structure. What I want to do instead is I want to go from the DSL to this pre-processed structure where I actually represent, okay, I have this structure here, I have this thing which is going to be a selector someday, this thing which is going to be a selector someday, and I actually want to have the structure of this with media thing represented in there. Okay, before I can explain more, I should go and explain mixins. Okay, whoop, that was what I wanted. Come back. All right. Yes, ignore those because that's other work in progress stuff. Okay, underline on hover, which is a lie because it's actually not underlining, it's just changing the color, but pretend it's underlined. Okay, so this is how you define a mixin in Elm CSS. You say mixin, and then you just start writing. You just say, I'm going to have this list of properties, and all of these are going to be for this particular mixin. The trick is that in addition to properties, you can also specify things that are not properties. So in this case, we have hover, which is actually going to say, cool, take whatever selector we've been building up so far and add the pseudo class hover to it, and then apply all the stuff I'm about to tell you to that. So that's how this underline on hover thing, so we define the underline on hover mixin. Let's see, what is it? Mixin underline on hover style sheet, yeah. So I'm saying A, and then I'm giving it the underline on hover mixin. And doing that means that I now have two declarations. So even though this in the style sheet is just one property, I'm just saying underline on hover. And by the way, this is just a normal property like anything else. So I can still say color blue, display none, thereby undoing all the work I just did. I can just go on, width px100, and this will work. So underline on hover is, despite the fact that it is a mixin, it just works like any other property. It sort of just drop it in and it works. And what it does is it brings in all of those styles that we defined up there, which is to say this color, so we can see that there, 128, 127, 126, and then on hover, 23, 24, 25, which is how it takes the selector we've been building up so far, which is just an A selector, but if we'd had other fancy styles and stuff, classes and IDs and so forth, it would have brought those along too, and just sticks hover on the end and prints that out. So, all of which is to say that this is only possible because we have this intermediate structure for mixins. So this is not a property, obviously. This is, we're saying, take the current selector and modify it with additional properties. Whereas if we were actually using the like normal CSS, hover would not be a property. Hover would just be a selector, and we would have to do all this at the top level. We couldn't say take the current selector we've been building up and modify it like this. Okay, so that's mixins, and so mixins are pretty integral to this whole pre-process thing. Specifically, they break down into these different operations that you can do. So one is you can append a property. So actually, this is something kind of interesting. Let me get rid of this. So the way that I'm able to say all of these mixins just work and you can just drop them in is that actually every single thing in here is a mixin. So background color takes a color thing and then returns a mixin. So when I say background color, background color green, when I'm like button background color green, in my style sheet, what that's actually doing is this is returning a mixin. So what this button thing takes is a list of mixins, and we can actually see that. Oh, that's over in elements. Yeah, so button literally takes a list of mixins. So technically, it's not actually the case that you're giving these selectors a list of properties. Technically, you're giving them a list of mixins. It's just that properties in Elm CSS happen to be implemented as mixins. I don't know if I just blew anyone's mind or if everyone's totally lost, but as previously noted, I'm just going to keep rolling until someone shuts me up. Okay, so we have so we can sort of see this in a new light now. So what's actually going on here is we're saying header, which we can actually look at the. Okay, let's go back to two-column mode. So header. You know what? Let me elements. Go back to this one. Okay. So header takes a list of mixins and returns a snippet. Snippet being essentially selector and then some declarations in progress that we're building up. So header takes this list of mixins right here. So background color followed by color returns a mixin, box sizing border box returns a mixin. If we define a custom mixin called like I don't know, funky opacity, and the way that would look is just opacity equals mixin, and they would say like opacity, I don't know, 0.3, which, as we all know, is the funkiest of the opacities. So this would just work. That's all I need to do here to make that happen. If I wanted to add a type annotation, I could. I could say this is a mixin, and that would be a true statement. But I don't have to. Type annotations in Elm are optional. Okay, so that's what's going on with all of those. And so that's header, takes a list of mixins, returns a snippet, and so do absolutely all of the other selectors we have going on here. What all of those end up doing under the hood is getting processed by this file. So when I say I have a mixin, the simplest kind of mixin there is just an append property mixin. So that's how background color is implemented. It says the type of mixin that this is just one of those mixins that just appends a property, and the property is background color. That's all it does. Another one we can do is extend selector. So extend selector is like that hover example we saw earlier. It's saying, cool, I'm going to take that existing selector that we've been building up in the course of defining all this stuff, and I'm going to add something to it. In this case, hover. And then takes another list of mixins that get applied in the context of that new extended selector. So in the case of hover, we'd say like button, hover, and then I don't know, color blue. So under the hood, what hover is doing is hover is returning an extend selector mixin, which is taking, it needs another list of mixins, which is this list right here. And then all the hover function itself is doing is it's specifying what the selector that we're doing is to extend the original one. In this case, the structure.repeatable simple selector we'd be doing. So I'm sure everyone has a perfect memory of all this stuff that I'm going through at warp speed. The repeatable simple selector is classes, IDs, or pseudo classes. So in this particular case, we would choose the pseudo class called hover. And that's what would go here. And then at that point, we have all three of our components for an extend selector, or both of our components for an extend selector. So we have our repeatable simple selector, which is hover pseudo class, and we have our list of mixins, which is the ones that the user of Elm CSS provides to the hover function. Okay, so extend selector works that way. We can also nest snippets. This is for essentially doing chaining combinators together. So in CSS, you might want to write button with a child of span. The way you do that in Elm CSS is by saying children, and then inside here, we don't actually give it mixins directly. We would say something like span, and that span has color blue. So what I just wrote up there would compile to button with a child of span has a color that is blue. Okay. And the way that we implement this children mixin is by using this thing called nest snippet. So we give it a selector combinator, which in this case we would give it the child combinator. We could also give it the adjacent combinator or the general, I already forgot the name of that thing, general sibling combinator, or we could give it the descendant combinator, which actually there's a CSS4 spec that says you can do this if you want, but which pretty much everybody just uses white space for. So you specify that combinator and then the list of the snippets that you want to have that relationship that you're setting up. Then you have with pseudo element, which is again if you want to do like after. Come on. Then we would have a button after. And then span would not make much sense there because this actually takes a list of mixins instead of a list of snippets. So we wouldn't say span, we would just say color blue. So it would look like that. With media queries works as you would expect. And then finally, apply mixins, which is just if you want to make a mixin out of other mixins. So this is how you can end users can define their own mixins using that mixin thing. So basically, the only function that uses this last apply mixins thing, I think, if memory serves right, is the one called mixin. So that's how I can write funky opacity. Where'd that go? Did I keep that or did I delete it? I guess I deleted it. before it was in a different file. At any rate, the funky opacity is mixin S0.3. This is how I can do that, is using this apply mixins mixin. I'm just saying, yeah, apply all these mixins, just do them all right in a row. Okay, so that's sort of the structure of mixins under the hood. And now I just basically build up my sort of intermediate representation of what I want using mixins, snippets. Snippet declarations very closely mirror the structure declarations because it's just a bunch of style blocks and properties and things like that. And yeah, so okay, so basically at this point, the only other difference here is that we have this list of warnings that we're building up. So warnings are for things like, what if I specify RGB in raw CSS here, 8, 8, and then taco. That's invalid. And we know it's invalid, and we can actually, well, so this is a bad example because taco would be a type error, but it is 999. They're supposed to be between 0 and 255. So that's an invalid color value, but that's not something that we can prevent at compile time because Elm has a type checker but doesn't have a value checker per se. So the way that I do that is I have color goes through and verifies its inputs when you're actually running, when it's actually building up the CSS file, and it'll generate a list of warnings. For example, you have something that's too high, so let's look at that. Where is... Oh, you know what? Let's look for 255. That's probably... There we go. Yeah, so this is basically whenever let's look at RGB. If red is less than 0 or it's over than 255, if any of these things are wrong, then it says, hey, I'm going to give you back a warning, which is that RGB color values must be between these things. Otherwise, we don't give you back any warnings. So doing this, as you're going, we can generate this list of warnings, but these get stripped out before they make it to structure, because again, structure's job is not to care about what's going on in Elm CSS. Structure's job is just to say, how do we model a valid style sheet? And so properties here are just the CSS properties, whereas in the preprocess step, they also incorporate a list of warnings that have been sort of discovered about that property based on what the user put for that property. So I guess we're almost there. So at this point, the last piece of this is what do we do with that intermediate representation? So at its simplest, we can just say we're going to take these normal DSL things and we're just going to build up this preprocess structure, and then we're going to have a step. This is called resolve, and resolve's job is literally just to take all of these. It's to take a preprocess structure and turn it into a structure, which is the thing that gets compiled to CSS. So in other words, resolve's job is to do this. It says, okay, given that we already have one of these preprocessed structures, turn it into a CSS structure, and then structure knows how to use prettyprint to turn that into a CSS file. And the DSL is just a bunch of convenience functions for generating this preprocessed structure. So we now have all those pieces, but basically at this point, it's kind of like, well, we have this nice, convenient intermediate representation of all of our mixins and all of our structure of our style sheet. And then we also have another one later, which is right before it gets turned into CSS, after all the mixins have been resolved and flattened out into specific declarations. Why not use that? Why not make it possible to write transformations against those so that we can have plugins? And this was not my original idea. So originally that namespace feature that we saw earlier, where it was prepending homepage to things, that was something that I wanted, so I just baked it into Elm CSS. But over the course of realizing that I wanted to have these intermediate structures, Evan pointed out, hey, you've got a compiler here at this point. So why don't you just represent features like that namespace thing as transformations over these that you can just hook in? So that's what I did. So I actually pulled out the entire namespace feature and made it be its own thing. So now there's this totally separate module called namespace, and homepage CSS imports css.namespace, but nobody else knows about it. So preprocess doesn't know about it, structure doesn't know about it. It's just this totally independent, decoupled thing that's completely optional, which is why if you want, you can just say style sheet and not even bother with using the namespace feature at all. So the way it works is it basically takes a list of snippets, which is to say the style sheet that you've been building up, and returns a transformed list of snippets. And so it does that using this thing called apply namespace to snippet, which essentially goes through and traverses the entire structure, and in a lot of cases does absolutely nothing. Like it ignores page rules, it ignores font face, does not ignore keyframes because it needs to namespace the animations, ignores viewport, ignores counter style, ignores that. So in all of these cases, what it's doing is it's just saying, okay, is this something that applies to me? Is this something I care about? In most cases, the answer is no, but in the particular cases of IDs and classes, it is something we care about. So we stick that name, the namespace, on the front of the class or on the front of the ID, but not on the front of the pseudo class, because that will totally break it. And then by the end of it, it's transformed all of this, and now this preprocess structure is a different one than what we started out with. So the end user wrote this whole DSL, and then they said, as we had here, okay, I want to take all of that, and then I want to run it through this namespace transformation. The namespace says, got it, totally cool. I'm going to let you build up your style sheet as normal, and then I'm going to transform that preprocess structure so that by the time it gets to the end of the pipeline, your classes and IDs and animations all have this prefix applied, this namespace. And all I had to do to implement this as an end user is I just use this normal function composition. This is basically saying I want to take these two functions, style sheet and this namespace thing, and just stick them together, just glue them together and make a new function. And so now I can do this with anything I want. So there's actually somebody, Luke Westby, is working on an auto prefixer one of these. So let's say I want to now have auto prefixer run on all these. Okay, I could use like literal auto prefixer if I wanted and just have it in a separate post-processing step, but why would I when I could just do this? Let's do that. Just stick an auto prefix step in there. I'm like, cool. Now it's going to go through and run a transformation where every time it finds some particular property that is supposed to have prefixes in various browsers, it can just go through and duplicate those definitions and generate the appropriate vendor prefix equivalents for all of those. And all I have to do that is something like import css.autoprefix, assuming that module exists, exposing autoprefix. And that'd be it. And again, totally decoupled, totally a plugin that anyone can write just as a transformation on top of these pre-processed things. And it just works. And that's all possible because of all of these cool things. The other nice thing about this is that, again, because at this point in this structure, we have this representation that is designed to emit valid CSS, it's actually pretty tricky for someone to accidentally make a plugin like this that breaks your stuff. Because at the end of the day, it's still got to have at least a structurally valid style sheet. I mean, yeah, they could go through and mess with your selectors and make them wrong. But semantically speaking, like structurally speaking, it can't like accidentally go nuts. It would sort of have to almost be intentionally malicious to do something like that, unless it was doing some really, really crazy, dangerous stuff with your, changing your selectors, like actually modifying strings, which of course it could do. So anyway, in the course of just sort of designing this and trying to make it easy for myself to maintain and debug, I sort of accidentally ended up with something that is Sass plus post CSS in Elm. And that's essentially what Elm CSS now is. So we're at about pretty close to 90 minutes, and I remember that was the top end. I feel like I'm going to leave 5 minutes for questions because this seems like a good stopping point. If anyone has any interest in working on this, there are actually a ton of really easy features to implement because one of the goals of the library is to oh yeah, color mixing. That's another thing that's possible here. There are a ton of keywords that I just have not gotten to implementing yet. So there are like font keywords, filter, column, background, miscellaneous. Actually, Flexbox, I think somebody did Flexbox. I just haven't checked it off the list. But basically, in order to have a nice sort of type-checked experience with this, where if you misspell something or you use an invalid property, I have to, or somebody has to, implement all these things by hand. So, for example, we have what's something end user facing. These are all under the hood things. Yeah, sure. HSL or RGBA or RGB. All of these, if you want to use them in a nice, friendly DSL, hanging each line. Did you know there was a text indent called each line? I think somebody implemented this. It wasn't me. I don't remember who did that one. Text transform, capitalized. We know about that one. Uppercase, lowercase. Full width. Didn't know that was one. So these are all things that people write. They're pretty simple. They're a pretty easy way to get into Elm if you want to just grab one of these issues and just comment on it and say, hey, I'd like to take Flexbox, or I'd like to take, well, don't do Flexbox because somebody already took that one. But like, I'd like to take filter. Nope, I said I'm going to take this one. Okay, but point being, there are lots of these. And if anyone wants to, man, I'm just like 0 for 3 here. People just keep grabbing these things.
I know, it's so hard when people contribute. I mean,
it's a rough life when we have an awesome community. At any rate, I guess find an issue if you're so inclined, or just hit me up on Twitter, RT Feldman on Twitter, and love to have contributors, and contributors have done an awesome job with this so far, and hopefully in the course of the past almost 90 minutes, I've made some semblance of coherence happen, and B, you learned something. So thanks for having me.
Yeah, Richard, that was fantastic. I've seen people read source code, and that was smooth as silk, my friend. You know your Elm. If there were any doubts, and I don't think there were, the doubts are now put to rest. Amy, any questions for Richard before we sign off on this episode?
I don't actually. He answered my one question at the end about the vendor prefixes, so that was going to be my question. But
yeah, it's kind of cool. The issue on this was like there was a debate as to how we should do this, and I was like, hey, check it out. Turns out we can just do this as its own thing. And then Luke's like, great, I'm going to make this. So yeah, he's just implementing it as a third-party thing that you can just add. It's pretty cool.
Yeah, it's great to see so much contribution around it. I mean, when you get the contribution when you know it's not production ready, and all of a sudden it gets a little closer to production ready a lot faster.
Yeah, exactly. It's always great to see.
Goes back to my point, too, about taking something that seems like it could be scary and it's not so bad. So
yeah, and
this was easier to follow than I anticipated personally. So.
Oh, great. Yeah, I mean, well, I'm super grateful for all the contributors we've had so far, and would love to have more. So if anyone listening out there is so inclined, please find me, and I would love to help you get started on diving in.
Well, again, thank you so much, Richard, for coming on the show today. Thank you, Amy, for also being on the show. This has been another episode of Read the Source. You can check the website for upcoming other shows. And we are now signing off.